Hello, it's Angus Webb, CEO at Dynamon, and in this video we're going to talk about our latest product called Precision Trial Analytics, which helps you conduct more accurate and conclusive trials. So the purpose of a trial is to measure the performance of the hardware or the operation as accurately as possible to know what's better to do. Is it a better procurement decision? Is it a better intervention for driver behavior or anything like that? But the problem with trials is that in a very complicated fleet environment, it's very difficult to measure anything accurately. So we've designed Precision Trial Analytics to make trials significantly more accurate by controlling all those critical variables and providing the correct data analysis to come to very accurate and conclusive answers so that you can make better procurement decisions to optimize your fleet. So let's take a look and see how it works. There are 4 stages to the perfect trial. Stage 1 is predict. You need to know what fuel saving you expect to measure in order to know how many vehicles are required and how long the trial should go on for. Stage 2 is design. You need to choose the correct vehicles for your trial to make accurate comparisons between them. Stage 3 is monitor. Throughout the trial, you need to monitor the vehicles to make sure that their behaviour remains consistent. And stage 4 is analyse. At the end of the trial, you need to use the correct data analysis methods to be confident that your fuel saving measurements are accurate and real. This video will show you how Precision Trial Analytics can be used to design the perfect trial. So we need to log into the Dynamon analytics system to access Precision Trial Analytics. So in here, Precision Trial Analytics is where you can design and manage a trial. So when you enter Precision Trial Analytics, you're presented with these 4 steps to design your trial. And this will tell you what vehicles you should use in this trial. So if we select the vehicles that we're interested in being contenders for our trial, in this case, all of our vehicles in our fleet, we're presented with the spread of performance of those vehicles. So efficiency being fuel consumption, litres per kilometre. Here's the spread in speed. Here's the spread in acceleration, and here's the spread in hill climbing. So what we want to do is we want to exclude extreme vehicles because we don't want them to be involved in our trial. We want a very well-behaved trial. So we can remove extreme vehicles. In this case, we'll just remove the extreme 5% of these vehicles. So Precision Trial Analytics has automatically excluded 8 vehicles based on the data we have here. So based on efficiency, speed, acceleration, and hill climbing, it's removed the extremes from that, which has taken 8 out of our set. So now we're down to 32 vehicles are allowed to be in this trial. This section is about fuel performance. Obviously, most trials are interested in measuring is something more fuel efficient than the rest of the fleet. So in this case, we're going to look at a fuel saving solution that we want to measure. So we're going to compare 2. You can see we can compare up to 10, but in this case we're going to compare 2 solutions. We're going to compare a baseline and a new. So if we take a pause for a second, we're going to go to a tool which enables you to predict the fuel saving you're going to get from your trial. So if we go into tyre analytics, we can run a quick prediction on some alternative tyre choices. So here we're going to very quickly change the tyres on our vehicles to see how much fuel we expect to save. So we've changed from a mixed performance tyre to a fuel performance tyre on each axle. And here we see how much fuel we expect to save. So in this case, we expect to save about 4% fuel consumption. This graph down here tells you how the fuel is going to change throughout the life of the vehicle. So we expect to go from about 0.29 to 0.28 litres per kilometre, changing from the current tyres to these new fuel efficient tyres. So back here in Precision Trial Analytics, we have our current fuel consumption, which was 0.29. And we're going to assume that that stays the same over the course of the trial, over the 12-month, up to 12-month trial. Obviously, as tyres wear, the fuel consumption will change, and we can model that. But for the sake of this demonstration, there's no need. And we found that the fuel-saving tyres made the fuel consumption go down to 0.28 litres per kilometre. And again, we're going to assume that that's the same over every month of the trial. So these are our trial design parameters. In here we can set our trial length. So if we have a shorter trial, it's going to need more vehicles. If we have a longer trial, fewer vehicles. So let's just assume our trial is going to last 6 months. And finally, we're going to calculate the minimum vehicle number for our trial. So for our 6-month trial and our comparison of 0.29 with 0.28, based on the behaviour of these vehicles, we're going to need a minimum of 5 vehicles in each group. And it has determined that the trial is viable. There are 5 vehicles in that fleet that can be placed into groups. So the final part of Precision Trial Analytics, which is the really impressive part, is that it will go and find these vehicles for you in your operation. So if we click this button here, Assign Vehicle Groups, it is going to use a very sophisticated algorithm to work out which vehicles should be in each group to make sure that the 2 groups are very similar. So this is the group that are going to keep their old tyres, and this is the group that's going to be on the new tyres. Obviously, these vehicles are called Demo 34 and Demo 8, but these will be real vehicles in an operation. So you can see here that between the hardware group 1 and hardware group 2, which was tyres A and tyres B, the efficiencies today, before we change the tyres, is currently very similar. The speeds are very similar. The accelerations are very similar. The hill climbing is very similar. So that when the tyres are changed on group 2 to the fuel efficient tyres, we know that the measured fuel saving will be due to the tyres and not due to anything else, because we have managed these variables, we have controlled these variables, and that there is very little difference in them beforehand. And that's extremely important when designing a trial. So now that we know which vehicles are in our trial, we can then start the trial. We can say, right, these vehicles need to be fitted with the tyres that we've decided, and then we will run the trial for 6 months and we will monitor it. So that's how you design the perfect trial, to make sure that you've got 2 groups of vehicles that are almost identical, so that when you make a change to one of the groups, you know that you're measuring the effect of that change, such as tyres, aerodynamics, or a more efficient vehicle, for example. Join us in our next video to see how you can monitor a trial as it's happening.